All right, welcome viewers. Today we're going to go over an introduction to Unit 10, which is circles, and we're going to do lots of vocabulary today. So we're going to start with this example. Points B and D are points of tangency, which means that these lines are tangent to these lines. This is a radius, so we've got a 90-degree angle there. And we have some information here. They're asking what's the length of segment DC. So before we start, let's go ahead and put some information that we already know on there. All these radii are 5, which makes this the length of AC 8 plus 5. Are you guys with me? So that's 13, right? I'm gonna write that down. There we go, 13. And now this problem is just like the previous one. So I've got A squared plus B squared equals C squared. I know what A is. I don't know what B is. We're solving for B. And I know what C is. So let's go ahead and fill that in. And you can use either triangle. I just decided to choose the top one. (13 squared) equals 5 squared plus, what are we looking for? BC squared. So that's 169 equals 25 plus BC squared. Subtract 25 from both sides, we should get 144. Tell me if I'm going too fast. Take the square root of both sides. I'm getting BC is 12. Anybody? Oh, I forgot to put this on. Did you guys get BC is 12? Things are happening. All right. Welcome. Welcome, America. Welcome, Justin Bieber. We hope you enjoy this show. Okay. Is that what they're, did we answer the question? No, we didn't. Why did I write BC? I'm looking at here. Where's DC? Okay, so what I did was, and this is good to see, I chose this triangle up here. These triangles are congruent. This particular problem is asking for the length of DC, which is equal to BC. I solved for BC, but they're the same. So I should probably write DC equals 12 at the bottom here because that's what the question asked for, and then we can move on. And I could have chosen either of those triangles because they're congruent. How are we doing? And you could type that in there, but some of the stuff in these slides is not as important. We're moving on. Central angles. There are two important types of angles that we are going to learn about. The first one is called a central angle. It has a vertex in the center of the circle. Central means center. So we've got an example of a central angle right here, 50 degrees. Another central angle here, 200 degrees. This is not a central angle. Notice the vertex is not in the center of the circle. So we need to write that somehow. Central angles have a vertex at the center of the circle. Did I decide I want to do slide 13? No, we're going to skip that. We're going to go to slide 14. Major and minor arcs. So here we've got two central angles. This central angle, if you take a look at the arc on the other side, that's called an intercepted arc. We'll look at that vocabulary in just a second. But notice this red arc has the same measure as this angle. If you go around the circle, complete rotation, one full, that's 360 degrees. On the outside, it's the same 360. So the measure of the angle for a central angle is the same as the measure of the arc. And this is called a minor arc. Minor means it's smaller. This is a major arc. Major arc is greater than 180. And 180 degrees is semicircle. That's just exactly 180. So what do you notice and wonder about major and minor arcs? We're not going to answer that. Let's go to the next one. It'll be clear once we get there. This is what I was talking about, an intercepted arc. So when you have a vertex at the center of the circle, the measure of this central angle is the same as the measure of this arc. If you were measuring this arc in a length, then that's an actual length, like part of the circumference, which we are going to do, just not today. But we're talking about the measure of the angle of the arc in degrees, and that's the same as the measure of the angle. So what do you notice about the measure of the arc? We can say the measure of the intercepted arc is the same as the measure of the central angle, or something like that. How are we doing? You guys are like, we'll be better if you don't sit in front of what we have to put on our computer, Helbing. The measure of the intercepted arc is the same or equal to the measure of the central angle. So we're using the word equal here and not congruent, because measures of angles are equal. So if you're talking about a number, numbers are equal. Whereas if you're talking about the name of a segment or a shape like a triangle, shapes are congruent and numbers are equal. We are going to move to slide. Let's take a look here. Slide 17. What is the measure of the major and minor arc? Okay, well, we can clearly see the measure of the minor arc is equal to the measure of the central angle. That's going to be 50 degrees. The minor arc is the blue arc. That's the rest of the circle. So that's going to be 360 minus 50. And I'm pretty sure the calculator will just do this for you. Yeah, here we go. Done, 310. Everybody good with that? The minor arc here, the blue arc, is 310 degrees, and the major arc is 310 degrees. The minor arc is 50. How are we doing? It's just vocab. It's new though, totally new vocabulary. I am going to move to slide 20. This is really where we're getting. So notice they're asking us to find the measure of each of these arcs. And notice a couple of the arcs have 2 letters, and some of them have 3 letters. A minor arc is written with 2 letters. So EF, we can tell it's using 2 letters. We know it's going to be a minor arc. It's going to be less than 180. The measure of this arc should be the same as the measure of this angle, so that's 120 degrees. So we can type in 120. These two, we have to be very careful about which direction we're going. E, C, F. E, and then we go to C, and then F. They're talking about this arc right here. Whereas CFE starts at C, goes through F, and goes to E. So the order of the letters tells you which direction you're going. And if you see 3 letters, you know it's 180 or greater. So ECF, ECF is just going to be 360 minus the 120. 360 minus 120. And CFE is 180. That's halfway around. I think that's it. Any questions? Going once. Going twice. All right, thanks for coming out.